Hi guys, thanks for checking in. This lesson is an interesting lesson. It deals with something that is called cubes and cube roots in math class. I'm guessing some of you have heard of this before, but I'm doubting that any of you have ever really done any problems like this before. Now, before I really get too far into this lesson, or I start really explaining what is a cube and what are cube roots, I want to back up for just a minute and talk about the concept we've been talking about for a few days prior to this one. And we have been talking about squares and square roots, right? Whoops. There we go. A square, well, yeah, you guys know the shape of a square, and we talked about how that applies to finding the square of a number. For example, what does 5 squared mean? Well, that means you've got a square that measures 5 for the length and 5 for the width. So if we were going to be finding the area of that square, you would be taking 5 times 5, which is really 5 to the second power, right? And we call that 5 squared. And then the answer to that would be 25. And then from there, we took it one step further. We kind of backed the process up, and we found something called square root. And I'm going to do that over here on the right. A square root is, like I said, it's kind of when you think backwards. This is the radical sign, and that indicates that you're going to be finding the square root of the number inside. So I'll use 25. That is a perfect square. And you kind of have to think to yourself, well, the square root of 25 is what number times itself? And then the answer would be 5 times 5. So the square root of 25 is 5. Now that's a review, a very, very quick review of squaring a number and taking the square root of a number. And I wanted to review that because finding the cube of a number and taking the cube root of a number is a very similar process to squaring and square rooting. So you can see here on this sheet that I have created a cube, right? Like a box, a Rubik's Cube. And in a cube, like a Rubik's Cube, the length and the width and the height, right? There's this new dimension here, the height, are all the same measurement. So here I'm using the variable a to represent that they all have the same length. The length is a, whatever a is, the width is a, and the height is also a. So if I wanted to find the volume of this cube, in other words, how much will it hold if I were filling it with sand or something, we would be taking the length times the width times the height. So a times a times a is a to the third power. So we'd be multiplying 3 of the a's together. And anything to the third power is called cube. It's like 3 dimensions. And a cube has 3 dimensions. So that's where the idea of calling this a cube comes from. So here's the definition there in green. When a number has been raised to the third power. And then I put in parentheses just so that you remember what that means. It means that it has an exponent of 3. Okay. There I kind of spelled it out. There's, a to the third power is a times a times a. And then down below there, I just said, well, let's just pretend that all sides of the cube measure 2 inches or 2 centimeters, whatever. So 2 to the third power would be 2 times 2 times 2. That is not 6, right? 2 times 2 is 4, and times 2 again is 8. So 2 to the third power is 8. And the answer that you get is called a perfect cube. So then down below you'll see I have done the first 6 perfect cubes for you. 1 to the third power is 1. 2 to the third power is 8. 3 to the third power is not 9, it's 27. 4 to the third power, 64. 5 cubed is 125. 6 cubed is 216. As you can see, these numbers get rather large rather quickly, right? So imagine what a number such as 9 cubed or 12 cubed would be, right? They get large pretty quick. Now, let's talk about cube root. It's kind of like square root. It's kind of like thinking backwards. The cube root is the number that was raised to the third power to get to the perfect cube, similar to finding the square root. So again, you've got that little symbol down there, kind of looks like the radical sign, except now you'll see that it has a tiny little 3 up in the left-hand corner. That means you're finding the cube root of the number inside that symbol. So that says the cubed root of 8 is, and the answer is 2. This isn't about dividing by 3. That's not how this works. This is like thinking backwards. So if I want to find the cube root of 8, I have to think in my head, what times itself again equals 8? Well, good thing for you, I listed up above, right, some of the more common cubes and cube roots that you'll be finding. So the cube root of 8 is 2, because it was 2 times 2 times 2. So hence the answer of 2. So the good news is that lots of the calculators that you have, either your own calculator or a calculator here in my classroom, lots of these calculators nowadays do have a cubic root function. It might be the second function button, so you might have to do some digging around in your calculator, and it might even look something like this. They'll show a radical sign, and it won't have a 3 like mine does right there. It probably won't have that 3. It'll probably have an X. It might have a 3. If yours has a 3, better yet. But if it just has an X, it means you're going to have to enter in your calculator what you want X to be. Then you'll hit the second function, and you'll hit that button. And then you'll hit the number 8. And that would find the cube root of 8, and you hit enter, and it would tell you 2. So you're looking for either an actual cube root function button on your calculator, or you're looking for the radical sign that has the little X instead of having the 3. You know, all calculators are different. I tell you guys that all the time. You're probably just going to have to do some tinkering around with whatever calculator you have handy until you get it to work. Okay, let's try a couple example problems, and then I'll turn you loose. Evaluate. What does evaluate mean? Right? You know that. It means solve. 4 to the third power. I know you want to tell me it's 12. It is not. 4 times 4 times 4 is 64. 7 to the third. 7 times 7, that's 49. Times 7 again, 343. 10 to the third, not 30, not 300. Because 10 times 10 is 100. Times 10 again brings you up to 1,000. So cube roots, or I'm sorry, not cube roots, but cubing a number results in a very large answer relatively quickly. A couple more. Let's work the other way. Let's find the cube roots. So at this time, if you have a calculator and you want to try to experiment with it and try to get it to find a cube root for you, that's great. Otherwise, what you have to do is ask yourself, what number times itself 3 times brings you to 512? Well, I'm going to click back to our last page for just a minute. What did we get when we had 7 to the third power? We had 343, right? And now I'm looking for some number to the third power that will give me 512. So I know it's got to be greater than 7. So try 8. What is 8 times 8 times 8? Or 8 to the third power? Guess what? It's 512. So the answer there is 8. How about this next one? 729. Well, notice that 729 is bigger than 512, right? The previous one we did. So the cube root of 729 has to be greater than the cube root of 512. So the cube root of 729 has to be greater than 8. So some number times itself 3 times. I don't know. Try 9. What's 9 times 9 times 9? that the answer? As a matter of fact, it is. And this one we already did, and hopefully you know. What number times itself 3 times equals 1,000? The answer is 10. The cube root of 1,000 is 10. You can't divide by 3. It doesn't work that way. All right? You kind of have to think in your head. And use your calculator if you have one handy. Hopefully you do. So the problem set for this lesson is not in your textbook. We're going to be doing these in class, and they are not from your textbook. So I will scroll through them. And you can pause this at any time if you want to work on these ahead of time. Oh, look at 4 and 5. We've got some positive and negatives on the outside. Yes, those are problems you can solve. Here's a few more. Notice that number 10 is in parentheses, and it's in parentheses for a reason, right? Because it's a -2 being raised to the 3rd power. So these are the problems we will do in class together. If you want to give them a shot ahead of time, go ahead and give them a try. Otherwise, I will see you soon.